A majority of our projects end with a presentation, and our students at our school, since the whole school is project-based, are used to seeing a standard type presentation where they present to the audience, and the audience can include their peers and also expert panelists and community members that come to assess them, and then they present their work and they get evaluating oral communication.
Team, send me one person. Okay, you've been through this before. We're doing gallery style. So you will grab enough of those for everybody on your team and dry erase markers if you're evaluating first. Okay, and you know how this works? These teams 2, 4, 5, 6, and 8 are presenting, and then the teams right below 1, 3, oh, me, and then 7 and 9 are gonna be evaluating, and then we'll just rotate to a higher number. We have 2 guest panelists, Dr. Marshall, it's right there. She's from UTeach, and before that life, she was a higher energy, middle energy, somewhat high energy physics. That's funny, I'm low. I was smaller physics. And this is Dr. Walker. She's also from UTeach. Yay. And before her life as a high school chemistry teacher, she was a biochemist. So do your best, project confidence. Also, they are so grateful that you allowed them to film this entire project that they have brought you Tiffany's treats. Have you ever heard of that? No. Cookies. Cookies from a very nice place. So we'll have cookies after we're done. Yay. Yay.
Another format that we'll opt for is called a gallery style presentation, which is what we did for this project. So in a gallery style presentation, you're either presenting or you're evaluating, and it's fast and loose. It's a very intense form of presentation, so what we'll do is we'll set up a rotation schedule where half the teams will be presenting and the remaining half will be evaluating that presentation. And instead of presenting their materials slide by slide in any predictable order, we have a pretty intense list of questions that are focused on content that they have to ask them, and they have to get through a certain number, and their oral communication is based on whether or not they can use the materials that they've generated throughout the project to answer these questions accurately and with confidence.
Okay, go to the team you're evaluating. Team 1, go by team 2. Team 3, go by team 4. I will go to team 5. Team 7, get over to 6. What is the haplozone?
Okay, the haplozone is where liquid water meets the planet, like the zone around a sun.
So do you have your orbits up? Because the second part of the question is to explain what happens to a planet just based on that. Okay, continue, Connor. Pick a planet and explain what's happening to that planet.
First I'll start with Earth, our Earth-like planet. It's right in the haplozone. It's right next to, therefore liquid water can exist on its surface. Our next planet is Earth, which goes through the haplozone and gets too close to its stars, so the water boils, and then it gets too far out where the water freezes. Therefore, no life can exist.
Okay, Stephen. How do mass and distance affect the gravitational force between 2 objects?
The larger the mass, the stronger the attraction would be. And 2, the smaller the mass, the attraction would not be as strong. And the closer the distance is, the stronger the attraction would be. The further the distance is, the weaker the attraction would be.
Okay, Michael. What is scientific notation? Give an example of a problem that's easier to solve using scientific notation.
Scientific notation is the way to simplify very large numbers, and we use it in the gravitational force equation.
Why?
Because if we put it in without scientific notation, it'd be really huge or very small, and that'd be a problem. So scientific notation, it changes it to where it could be like 2 point something to the 10th power, and the exponent, which would be 5, which we simplify and make it easier for us to solve it.
Okay. Connor, how can you tell the length of the major axis from the equation of an ellipse without graphing it?
Our attraction, no. Yeah, attraction to our star.
You double the A value or the largest radius.
Bring up an equation of an ellipse. Oh, they're very small.
Yeah, they're really small.
So point out an equation and show me which one is the major.
The major axis should be This right here, 250 square.
Okay.
I don't really know why.
Stephen, how can you find the center of an ellipse without any additional points?
The body diameter by 2.
Okay, Michael, how can you determine the C value given the center and the foci of an ellipse?
In your own words.
You know, the center and the foci on that graph. How would you find the C value? Okay. My advice to you is it's going to kill your con because your eye contact is not great. And you're using up a lot of your question time shuffling through the pages. So, yes, you're allowed to use it, but I don't recommend it because it's not working out.
The questions are so specific and so content driven that you can't just make these up, which you can do with some of your bullet points on your slides. So I warn them ahead of time, it's like the questions are posted. If you don't want to feel uncomfortable tomorrow, you may want to look them over. So some of the kids came in with like cheat sheets that were 20 pages long. At one point, I had to tell one team to put down your cheat sheet because it's ruining the interview. Like your over preparation is killing the interview because you're wasting half of your time trying to find the page with your notes.
Alexis, which of your planets experiences the greatest gravitational attraction to your star? Explain why this force is the greatest.
The greatest one would be our planet Gemini.
Why?
Because it has the smallest distance from the star. And the shorter the distance, the stronger the gravitational force is.
Okay.
One example of that, this is Gemini.
Okay. Brianne, explain how you use scientific notation to find the gravitational force between your star and one of your planets.
How we use scientific notation? Okay. So we had our mass of our planet and our star, and we plugged that into the universal formula to find gravitational force. And we use scientific notation because it's a lot easier to work with than having really, really big numbers. And so we just used it like that.
Do you have the calculation in these slides somewhere?
We don't have the calculations.
You can bring up the report. So give me some of the steps that you're going to have to do. Yeah, give me some of the major steps, like broad picture you'd have to do if you have this in science.
Okay, so this is the formula for gravitational force. We plugged in our masses and then our distance divided by our distance squared. And so we grouped like terms, so we put not the exponents, exponents, those on one side and then the actual numbers on one side to make it easier for us. And then we added up the exponents and then since we had a number greater than 1 through 10, we had to use scientific notation in our last step to move it over to make it 1 through 10.
Okay, first question is for Ashley. How can you tell the length of the major radius of a graphed ellipse without any additional points?
You would count from one end of the oval to the other end and divide that by 2.
How do you know that that's the major radius?
Because the major radius is the diameter. Because the major radius is it's b in the equation.
You don't have the equation, you just have a graphed ellipse.
Okay, well, so do we have the equation?
Yeah.
Can you repeat the question again?
How can you tell the length of the major radius of a graphed ellipse without any additional points?
You can see which one is larger, and then using that, you can like find the point. If you know the point there and the one there, then you can average them to find the center point, and then subtract the x value of the center point.
Okay, so you count the diameter from both sides, and you subtract that value by then you find your middle point, and then you subtract that x value of the middle point out of the radius.
Stella, first question. How can you determine the C value given the center and foci of an ellipse in a horizontal ellipse? It's fourth from the bottom on the front page.
Okay, it's how can you determine the C value given the center point? The center and foci of an ellipse, right?
Yes, in a horizontal ellipse.
Okay. Let me read it again.
Summarizing a number, a really long number.
You count the number of units between the coordinates on the x-axis.
Give me at least two characteristics of habitable planets and explain why these support life.
Okay. The temperature of the planet needs to be not too hot or not too cold.
What's too hot and what's too cold?
Too hot is boiling point. Too cold is freezing point.
Why is that important?
Because a person or plants can't live in too hot environment or too cold environments because they'll either freeze.
Can I give her a hint? Yeah.
The water will freeze or
Dosa, first question. How can you determine the foci of an ellipse given the center and C value in a horizontal ellipse?
You would solve for B and you would add it to X.
How would you solve for B given the center and C value?
Connor?
The C value is between the origin point and the focal point. How would you find it? Okay, so the C value is actually the origin. I mean the center of the ellipse, and from there to the focal point, that's the C.
Okay, so would you solve for A and then add for X?
What?
Do you want to finish the explanation?
Yeah. So basically,
Horizontal ellipse.
horizontal. Alright, well, what you would do is once you have a C value, what you would do is you would just take the center point of the ellipse. For example, here it's at this point. It's a little bit over the origin point. And what you would do is you would plus or minus it, considering which way it's facing. Either side of the
Okay, so if you're finding both of them, what do you add or subtract it from?
you add the C value to find the rightmost, and then subtract the
What do you
final.
add it to or subtract it from?
Like if your center was the origin, and say your C was 10, then you would plus, you would add 10 to that, and that would be your focal point.
So what would that mean focal point?
That would be 10, 0.
How can you tell the length of a minor axis of a graph ellipse without any additional points?
Wait, what question is that?
How can you tell the length of
No,
a...
like on the paper.
Oh,
It's hard to say. Just listen carefully.
5. Fifth question.
1, 2, 3, 4, 5. How can you tell the length of a major axis in equation on the next whatever? If you look at the equation, there's going to be two numbers, and for the major axis is the number that is bigger in that equation.
Which two numbers are you talking about?
Sorry. It's going to be like for this one, it's going to be this number and that number, so it would be the one who's larger, which would be 182.5.
Casey, how does the acceleration due to gravity on one of your planets compare to the acceleration due to gravity on Earth? Explain why this gravitational acceleration is larger or smaller.
Okay, so on our planet, Janet, the one that sustains life, that is in the habitable zone, so we assume it can sustain life, there the gravitational force is 4 times greater. Can you repeat the question?
What was the acceleration due to gravity on Janet?
4.44, which is 4 times, it's just about 4 times bigger than the gravity on Earth. So
What's gravity on Earth? The acceleration due to gravity on Earth.
not 9.8.
Yes.
9.8. So it's about 4 times greater.
Oh, you said it's 44. Go. Continue. Okay.
And so things on our planet Janet would weigh 4 times more.
Okay.